Good morning. Today we're going to go through how to find the volume of cylinders, and this is going to align with IXL assignment FHC. Let's do a quick little reminder first, because when we're dealing with cylinders, that is a three-dimensional shape. It kind of makes me think of like a Pringles can is the first thing that pops into my mind. When we think about a cylinder, both the top and the bottom of it are a circle. And so if we want to review a little bit about our circle vocabulary, we have radius and diameter. Remember that radius is the measurement from the center of the circle all the way to the outside. So it kind of goes halfway across the circle. And then the diameter, that's what's in blue here, that starts at one edge, goes through the center and all the way across. So the diameter goes all the way across. The radius only goes halfway across. So down here, if we want to compare the two together, that means your radius is half of your diameter. So let's say that you were given a diameter of 12 and you wanted to find the radius. You would need to take half of 12, which is 6. Or if we did another example, let's say you had a diameter of 18. To find the radius, you would need to take half of that, which would be 9. Sometimes the opposite version is true. Maybe you're given the diameter and you need the radius. So your diameter, since that's all the way across, that is 2 times the radius. So if you're given a radius of 4 and you want to find the diameter, you need to times that by 2. You need to double that. And 2 times 4 would be a diameter of 8. Or let's say we had a radius of 7 and we needed to find the diameter. Well, the diameter is twice the radius. So 2 times the radius, 2 times 7 is 14. All right, so now if we fully transition to cylinders, as I talked about cylinders, it just makes me think of, any sort of like a soup can or anything like that. Notice that, as I was saying, both the top and the bottom of that cylinder are circles. And because of that, when we're trying to find the volume of a cylinder, we are going to be using some similar things that we saw in dealing with circles earlier. One of those being the radius, and then the other is we're going to continue to use the number pi. So this right here is a formula that you guys need to either take a screenshot of or write down in your formula page of your notebook. Because in order to find the volume of a cylinder, you take pi and multiply that by your radius squared, and then multiply that by the height of a cylinder. So we'll get to it in just a second. Even though this formula, looks a little bit crazier, it's a lot of multiplication, as we can see here. And with formulas, my favorite thing about them is no matter what you're using a formula for, the initial steps are the same. You identify the information you're given, you substitute, you plug that into your formula, and then you solve it. So let's go ahead and switch on over to IXL. All right, quick reminder, the IXL assignment is FHC, volume of cylinders. So we are asked, what is the volume of this cylinder? And we're told that we are going to use that was a weird line, but 3.14 as the approximation for pi. And if necessary, we'll make sure to round our answers to the nearest hundredth. And then we have to look at this image, we need to look at this picture here and get all of our information. Well, our radius, that is part of a circle. Remember, your radius goes from the center all the way to the edge. So that would be this right here. The 16 millimeters is our radius. Then our height is how tall the cylinder is. That's going to be our side right here. That's showing us the height. That's showing us how tall it is, which is 13 millimeters. Go ahead, take this moment and view your volume formula. And if you don't have that written down, make sure you pause the video or rewind and do so. So to find the volume of a cylinder, our formula is volume is equal to pi times radius squared times our height. So let's go ahead and we're going to substitute. We're going to plug the information that we've labeled into our formula here. We are trying to find the volume. That's our question. That's our unknown. So V stays V. And then we're using the approximation 3.14 for pi. That is being multiplied by our radius squared. So our radius is 16. And then that is being multiplied by our height of 13. Now that we have all of this, we need to use order of operations to simplify and solve for our variable V. Remember, with order of operations, you can either look at it as PEMDAS, or I know some of you, like me, like to look at it as really GIMDAS. That G is for grouping symbols, because it doesn't just include parentheses. It could include brackets, absolute value bars, etc. If we look at this, we do have parentheses. But in this case, our parentheses are meaning multiplication. They are not a group. When I look inside the parentheses here, I don't have a group of things. I just have the number 13, or I just have, the number 16. So I technically don't have anything to do in that first step. But when I look at the second step for E for exponents, that I do have. But we always need to make sure we do our exponent first before any other multiplication. And that would be 16 squared. Remember that the exponent tells you how many times you multiply that base. So in this case, our 16 is being multiplied by itself 2 times. So that really just means 16 times 16. You are allowed to use a calculator for that. So you can type into your calculator 16 times 16, which is 256. And then I'm going to bring everything else down. Now we're just left with multiplication all the way across, because all of these parentheses here mean multiplication. And so we can use our calculator to multiply these 3 things together. Just a quick little detour here. If you don't have a calculator or you want to use my favorite one, it's the Desmos Scientific Calculator. You can just, you see the website address up here, or Google's pretty handy at finding it. I like this because it's very similar to the one that you'll see on the FAST test, so it kind of gets you familiar with the buttons and where everything's located. But we can just do our multiplication. Once I get this typed in, I will clear the screen so we can see it better. Just don't want to forget any of the numbers. So we had 3.14 times 256 times 13, and that gives us, that's a big number. Looks like we have 10,449 and 92 hundredths. And that answer is already rounded to the nearest hundredth. There's 2 decimal places, so we don't need to do any additional rounding. That would simply just be our answer. We don't need to put a comma in, but you do need to make sure to put your decimal point in. So the volume of this cylinder is 10,449 and 92 hundredths cubic centimeters. Let's try another one. We want to know the volume of this cylinder here. Once again, we are being told to use the approximation 3.14 for pi and round to the nearest hundredth if that's necessary at the end. When we look at our image here, we need to identify the information we're given. Remember, the radius is always part of your circle. So that's the top half there. It's going from the center to the edge. So 17 meters is our radius. And then your height is how tall something is. That would be right here, the 18 meters. Our formula for the volume of cylinders is pi times, oops, I was going to color code that. Volume is equal to pi times radius squared times height. So if we substitute, we plug in all of our information. The volume is what we're trying to find. That stays a variable. And then pi, we're using 3.14. That's being multiplied by our radius of 17 squared. And then that's being multiplied by our height of 18. Once everything's plugged in, we go back to using order of operations. I'm going to show you a slightly different way on this one, because we know that we need to start, with that, exponent. We need to recognize that this isn't just a 17, it's a 17 squared. If we wanted to, we could rewrite this to show what 17 squared means, which is 17 times itself twice. So we have 17 times 17 times our height of 18. And then that's just pure multiplication all the way across, and you can plug that whole thing in your calculator. So if you'd rather look at it like this, that's totally acceptable, as long as we recognize that the radius is squared, which means we have to multiply, in this case, by that 17 twice. And then I can just type it into my calculator, 3.14 times 17 times 17 times our height of 18, and whew, that is a big number. We have 16,334 and 28 hundredths of, and let's see, our label is cubic meters. So another way you can write that is meters cubed. And that would be our volume. This is a good one. This one is just a little bit different, but not too much. So once again, we are finding our volume, and we are told to use pi for 3.14, and then we have a diagram here or a figure to give us our information. Did they give us the radius in this problem? No, because if we look at the image, notice that dotted line goes all the way across. What is the name for the measurement when it goes all the way across a circle? That's the diameter. That means our diameter is 34 meters. But we need the radius in order to use our formula. Well, recall the relationship between diameter and radius. Radius is half the diameter. So we need to find what half of 34 is. When the numbers are larger, if that makes it difficult for you to find and just know what half of that is, remember, when you're taking half of something, that's the same thing as cutting it in half, as dividing it by 2. So you can take 34 and divide that by 2 to find your radius, which would be a radius of 17. meters. And then our height is 18 meters. All right, that required a little bit of extra work, a little bit of noticing, so make sure you don't go too fast when you're doing this on your own, that you really look to see, okay, did they give me the radius? If so, you're good to go. If not, and they gave you the diameter, you need to divide that by 2 to get the radius, to get the information that you need. This problem is pretty similar to the last one we did because our radius is 17 again. Kind of funny. All right, so volume is equal to pi, which is 3.14 times our radius, which you could either write that as 17 squared, or you can also recognize that that's the same thing as just 17 times 17, whichever way works best for your brain. And then that's being multiplied by a height of 18. All right, let's put this in our calculator and solve it. So we have 3.14 times 17 times 17 times 18, giving us a volume of 16,334 and 28 hundredths. And once again, it's already rounded to the nearest hundredth, so we don't have any additional steps that need to be taken. All right, let's close out with one more example here. Sometimes your problem is going to be all in word form. There won't be an image or a diagram to go along with it. In some ways, this may even be easier because it straight up tells you, height, radius, diameter, so there's no chance of potentially getting that information mixed up. So a cylinder has a height of 16 centimeters. It has a radius of 5 centimeters, and we are being asked to find the volume, and we're continuing to use 3.14 as our approximation for pi. All right, let's substitute. Let's plug these into our formula. The volume is equal to pi, which is 3.14, times our radius squared, which would be 5 squared, otherwise known as 5 times 5, and then our height of 16. Once you have that, you can plug it all into your calculator. So 3.14 times 5 times 5 times 16. There we go. And it gives us a volume of 1,256 cubic centimeters. All right, it is your turn to hop onto IXL, but a quick little reminder, IXL has some help for you as well. You can click on this to learn with an example. It'll go through step by step how to do it. And then there's also a video that IXL has made. Sometimes it's nice to hear it explained from a different person and a different voice. It can make things click. So check out those 2 resources if you still have some questions. And then once you get going, if you need anything, reach out to your teachers. All right, good luck, guys. You got this.